3 out of 4 chairs. That's as good as we could hope for, I suppose.
Ron, can you upload Tom Herbert's slides?
Hang on just a second. Okay, Ole, if you want to start the meeting while I do that.
I can certainly do that. So welcome to this V6Ops 6-man joint working group session on the hop-by-hop extension header behavior. You have gotten used to the note well by now, so note it well. We have Barbara again, who's volunteered to take minutes for us. Thank you very much, Barbara. No Jabberscribe, as we don't practice those on online meetings, or with Miteko, we probably don't practice them anymore at all. The speakers, the presentations are uploaded to Miteko, so the speaker should just go and press the share preloaded slides, find their slide set, and share that. They can run and control the slides themselves. So here's today's agenda. We'll just start off with this little introduction. Then Ron will go through the goals of the meeting. Then we'll have a section on the requirements and solution drafts, basically more meat on the problem, if you like. A set of example use cases, just lightning talks on those, just to give an idea of how hop-by-hop is used today. And then we hope to spend most of the time at the end of the meeting discussing where we want to take hop-by-hop, if you want any changes or improvements to the hop-by-hop extension header. Any comments on the agenda before we move on to the main topic? No? Then, Ron, it's your turn. Do you want to share the slides yourself? Or do you want a hand?
Yes, I can share them.
Excellent.
Hang on just a second. Click, click, click. Let's find the right slides.
And here comes Fred, our last co-chair. So welcome, Fred. Good morning.
Ah, here they are. Okay. Good morning, all. And we're going to talk just for a minute or two about the goals of this meeting and how we got here. Page down. Oh, this way. First, a bit of history. The hop-by-hop extension header has been with us forever. It was first specified in 1995 in RFC 1882, then again in 1998 in RFC 2460. The router alert option was specified in 1999 in RFC 2711. And that was actually an unfortunate first application of the hop-by-hop extension header. The hop-by-hop extension header can be used two ways. One way is to influence how a packet is routed, as are most of the fields in the base IPv6 header. Another way it can be used is to influence the control plane. The router alert option was used that way. So because it was used to influence the control plane, many implementations punted packets containing the router alert option to the control plane. And unfortunately, this caused the router alert option to be a DOS vector. Then many implementations just punted all packets containing the HBH to the control plane. And this caused all packets containing HBH to become DOS vectors. That made bad things happen. Network operators filtered all packets containing HBH. People didn't use the HBH because they knew it would be filtered, and we had this kind of cycle of failure for the HBH. Well, something changed in RFC 8200, and it's this note that you see on the right-hand side of the slide. Initially, all nodes had to process the HBH options, but now it was expected that a node would only process HBH if it was explicitly configured to do so. So, what are we going to do here today? We're going to ask basically two questions. Does the current specification in 8200 satisfy the needs for IPv6 hop-by-hop extensibility? And can we expect the current situation to improve without any changes? So the questions for the session are, do we want to proceed with rehabilitation of the HBH option header? Do we want to take some other action, maybe deprecate the HBH option header? Do we need to re-examine currently defined HBH options? A lot of them are just hanging around for historical sake. Maybe the router alert option needs to be deprecated. And finally, what documents do we need to progress in order to make this happen? And at this point, I'll open the floor for anybody who wants to ask questions about what our goals are in this meeting. I see nobody on the queue, so I will be quiet and yield the floor to, I think Bob is the next presenter.
On the agenda, I think we have Xuping, but...
Oh, I'm sorry, Xuping is first.
Yes.
Yeah, hi, this is Gian Mishra. I'll be presenting for that draft, for the HBH options processing draft.
Excellent. Can you share the slides yourself, or do you need some help?
You know, I haven't done it before. Oleg, maybe if you could give me a hand, probably save time.
Okay. Let's see if we can find the presentation. Let's see. I think it is this one. Is that a correct slide set?
Yes.
Yes, excellent.
Yeah, that's it. All right, excellent. Okay. All right. Hi, my name is Gian Mishra, and I will be presenting operational issues with processing of hop-by-hop extension headers. So this draft, just in recent, I believe a few weeks or so ago, the draft was recently adopted. Since adoption, we've updated the name, and then we have a few additional updates to the draft. So in this deck, we're going over the updates and then the overall progression of this draft, and then as Ron had mentioned, I guess, you know, kind of segue into kind of the issues and all related to hop-by-hop extension headers, and especially kind of honing in on the focus of this draft and really the problem statement. And it's really now as this draft is a working document, really this draft is really applicable to really any issues related and really honed in on HBH options and what the problems that occur that exist today, and then how we can segue into breaking that cycle with related issues and not having to, I guess, worst case scenario, as Ron had nicely mentioned, deprecate HBH. So we want HBH to be viable, and that's really the goal. And that a lot of that is what we'll talk to in this slide deck. So next slide. So the changes that were updated after the adoption call. So one is the title. This is during the adoption call, and then we renamed it after that. So the title was changed as it was misleading, towards a solution. So anything related to solution space, we did quite heavily, and I believe it was in section 7 and 8. We removed anything that was solution space because we wanted to make this draft really cater to the work group, and we want the work group to be involved in helping develop and progress this draft. So the goal was really to completely eliminate anything solution related and make it generalized so it can apply to any solution to help make HBH viable. So the purpose of this draft clarified in both the abstract and introduction sections. Scope is also clarified in section 2. Additional references added, and it directly quotes specifications in existing RFCs where suitable, and then the requirements section. So there was a lot of updates that we had in the requirements section, and we cleaned up a lot of that. So anything in there was not pointing to solution space or any solution, and just making it more generalized and focused on the problem statement. And then section 8 says significant changes. Instead of being completed or deleted, we migrated it. We migrated over that were important to consider. So we just kind of did some more cleanup in section 8 as well. So really, section 8 and section 7 were really the ones where we did quite a bit of cleanup before and during the adoption call to get this document ready for to become a work group effort. Next slide. So as far as future work, so the requirements in section 7, they still need some more work, and we'll be conducting that in later revisions. So we would like feedback from the work group, and we appreciate really all the feedback that we had gotten through the adoption call, and the continued feedback, and any criticism. We definitely we're open to any changes, updates, or whatnot, as this is a work group document to help progress this document. The migration status strategy in section 8 is an important consideration, and which needs a work group, that we have to work. We would like to work with the work group together and get recommendations on migration strategies of how to make HBH options viable, and kind of a path forward, and that's really a work group effort to help make the viability of HBH options. As well as new sections on other network scenarios. They haven't been added yet, so there may be that may be some additional work, future work. So if the work group, as we progress, just really brainstorm and think of ideas, enterprise IoT or other use cases and scenarios related to HBH options. Next slide, please. So on the mailing list, there were some discussions related to the draft, and just really clarifications. And with this draft, and just comparing, there were some comparisons done with the goals of RFC 9098, and just kind of comparisons to this draft. So RFC 9098, it's a generic, and it's really talks to all the extension headers, and really the Christmas tree effect of the extension headers, and the limits on the number of options within each header, especially the HBH and destination option headers, but really talks generically to all extension headers. It doesn't call out specifically just the HBH, where this draft is really honed in, just solely honed in on the HBH options, and really trying to really identify the problem statement clearly, and the problem space, and kind of the endless cycle that with the misnomer with the HBH being a DOS vector, with older hardware, and now with newer hardware, kind of getting around that, coming around the bend with that, and now trying to get to the point where HBH can really be viable. So really honed in, and then solutions that where HBH, especially with developers, being able to use HBH as a viable option for telemetry, and there's a lot of space that can be used for HPH. So that's something that's really a goal, overall, and for the IETF, especially across all working groups, being able to utilize HPH, for a variety of use cases. Next slide. So motivations of the work. So since the very beginning, so HPH Options is a valuable container for facilitating these services, and that's really the key that we really want to kind of break the problem that exists with the endless cycle of HPH being, from an industry standpoint, being a DOS vector, and an impact of the control plane, punt to the slow path, and now making it viable. So with that, having that HPH option as a container, there are a variety of use cases, news services, telemetry, IPPM working group with any IOAM development, marketing, PM2D, and there's a variety, and there's probably a lot more to come. Once HPH really becomes viable, and we kind of break that cycle, a lot more development can come, and really the gain is the operators can really gain from this new development. Now we have this extra tool in the operator's toolbox to really help pave the path forward. So our main purpose is enabling the HPH options to be utilized in a safe and secure manner without endangering any operations, and then ease of deployment in network services and in multi-vendor operational scenarios. Next slide. So with modern router architecture design, so the main thing is this, I guess, strict separation between control plane and forwarding plane. And in older hardware, what would happen, and really the big thing is with the DOS vector, and really that having traffic it hits the forwarding plane, but actually all traffic, both forwarding plane and control plane type header options headers, being HPH options being punted to the slow path, to the control plane path, and that's really what with newer hardware and intelligence built into the forwarding plane. So, and being able to mitigate that, and now with interface, being able to control the forwarding plane and rate limiting mechanisms that can help protect the control plane separation, and that's really the big deal that really happens, I think, with operators, really across the board. The fear of not having that separation of control and forwarding plane, that anything that hits forwarding plane, whether it's a forwarding plane option or a control plane option, that everything getting punted, and that not having that complete separation, that has always been the fear, and so with the rate limiting, that helps, but that does cause inconsistent packet drops and impacting normal forwarding. So being able to process, and I guess with newer hardware, especially with MPUs, and as development happens, being able to process HPH options headers really in the forwarding place in path at line rate, and that's really the goal. And as a development, there has been a lot of development in the industry with modern routers and being able to handle HPH options. So the misnomer of not being able to process HPH options, I think that's something that we kind of want to tackle. And I think as this problem statement draft, gets adopted and becomes RFC, we can really help, at least with the industry, and kind of change that misnomer that HPH options is really viable, and it break that cycle that it really will not be a DOS vector. And now with intelligent MPUs being able to do that proper processing, with development as well with, let's say, Bob Hinden's draft, with restricting the number of options and other solutions that exist, any solutions that exist that really make it possible and viable. Next slide. So common implementation, so the values in the next header field in the IPv6 header. So and this is kind of really the big issue that it triggers. So when in the next header field set to the to options to 0, it's directly sent to the slow path. So the option type won't be examined before the packet is sent to the slow path. So, and that's really the standard kind of default behavior. So as traffic comes in, and that's really the fear that operators have with HPH, and that's why there's a rate limiting filtering and dropping with ACLs to drop it. So, and that's the common implementation that's been done with most vendors. As the development happens with modern routers, with MPUs, and moving away from fixed function ASICs to more specialized, I guess, architectures and even proprietary ASICs. But that ASIC development, as that happens, prior to being sent, the forwarding plane, we should be able to handle, HVH options at line rate, and with, possible restrictions on the number of options, as Bob Hinden's draft, has in that idea, and maybe other solutions that actually can help kind of clean that up. So making that forwarding plane viable, so we don't, punt traffic directly to the slow path. So, and historical reasons that, and then this is also something that what this draft really spells out in detail. There's an architecture section that goes into the control plane and forwarding plane architecture, and historical reasons of what happened with not having that separation and everything being punted to the slow path, and now newer ASICs and ASICs and NPUs being able to really have the ability and can handle HVH options. So that's really the goal. That should kind of change that mindset for operators, and then implementation as well. Now, at least across the board, being able to handle the processing. Next slide. So standards specifications. So RFC 2460 required that all nodes examine and process hop-by-hop options header. RFC 8200 now expects that all nodes along the delivery path only examine and process the hop-by-hop options header if explicitly configured to do so. So that was a big change from 2460 to 8200. So now there's a local configuration that, depending on the node itself, whether if it can process that, to process it only if it's capable of processing. So that does help, as for operators as well, to not have to have that fear of that separation of control plane or forwarding plane, that nodes that are maybe down rev, that they can avoid, and with local configuration to avoid having to process HVH options if they're not capable of doing so. And then as well, RFC 8200 nodes may be configured to ignore, drop, or assign packets containing the HVH options to the slow path. So with current situations of various configurations and operator networks unable to support service deployments and disturbs normal IP forwarding. So that's really kind of the big issue, and especially on the public internet, as well as private MPLS, and internal networks. But anywhere where you have HVH options, I think the fear of that not having that control plane separation, control and forwarding plane separation, when HVH option comes in, either you're dropping it, rate limiting it, or being punted to the forwarding path, and the ignore is really the biggest thing, that you're ignoring it. So now that feature of being able to use HVH options reliably and having it be a feasible solution for developers is really not possible. Just the way things stand today is with that ignoring or punt to the slow path or drop. Next slide. So operators typical processing. So many operators deploy ACLs that discard all packets containing HVH options. So this is with this draft, the honing in on HVH and trying to just change that mindset for operators to not do that, as with the development and with modern routers and development, that HVH options can be viable, and there is with your architectures that we have that with that separation of control plane and forwarding plane. RFC 6564 reports from field indicating that some IP routers deployed with global internet are configured either to ignore or drop packets having HVH headers. RFC 7872. So many network operators perceive HVH options to be a breach of separation control and forwarding plane, which I mentioned. Several network operators configure their nodes to discard all packets containing the HVH options. So kind of making it really not viable and then other configured nodes are forwarding packets but ignore HBH options. So the ignoring, dropping, and then the punt of control plane. So there are overall just a lot. The operators typical processing is really kind of deny, drop, or not forward a rate limit. Then that's really been the typical kind of business as usual method of dealing with HBH and making it not viable.
Excuse me.
The consequence. Yes, sorry.
If you want to leave time for questions, you might want to be
Speed it
wrapping
up.
up pretty soon.
Yeah, let me just thank you. Thanks, Ron. Go next slide. Let's see if I can breeze through. All right, so shall we break the endless loop? So that's the biggest thing here. We want to really make HBH viable, really break that kind of mindset for operators with development of and new implementations and updated implementations across the board with vendors, making HBH viable and being able to process HBH options, not having that mindset that it's a DOS vector, and getting out of that mindset that we have to drop and we got to discard deploying ACLs to drop HBH options. So we'd like to, with the community, internet community at large, we'd like to break the loop, this continuous loop of, not having HBH really be reliable, because of the mindset with the operators, breaking that loop, fix the problem, so the problem exists, and then try to make HBH viable with processing and having feasible solutions, such as I mentioned, Bob Hinden's draft with the limit of the number of HBH options and other solutions that may be out there, fixing that problem and make HBH options actually be able to be a viable solution that can be utilized by operators in their operator toolbox. Now allow better leverage of the HBH capability. Next slide. So we've collected requirements, on reasonable solutions. So there has been, we've gone through. I mentioned Bob's slide, and he'll be talking about that. I think it's up after this. So that's really the big one. And I'm going to skip through this slide. That Bob will be digging into that, I think, in his presentation. Next slide. Thank you. So, question and comments.
Okay, I think to stay on the agenda, we should probably move on. We have a 25-minute Q&A session at the end of the meeting, so let's hold our questions till then.
Thank you.
Bob?
Gory was also going to present. Let me see if I can figure out how to do the slides.
Hi everyone. Hopefully I'll be complimenting Bob in this talk.
Or the other way around. Wait, which?
Feel free to share your video, Gory, so we don't sit up here alone.
Do you think that helps? Here's my video.
I'm not seeing the deck. Oh, someone is doing it.
Did you find it, Bob? No?
No, it didn't.
Let's see. This is not a minimum. No, it's not a minimum one. IP6 hop by hop options processing procedures.
That's it.
This one?
Yeah.
Yeah, I can share it for you.
Thank you. Good. Yes, Gory and I got involved in this when we were working on the PathMTU option. Gory and his university did a number of data collection to sort of figure out how well hop by hop options worked, and we quickly discovered that they're dropped a lot, especially at the edge. And so it was, so we started to think about how could we improve processing of hop by hop options. Yeah, there's been a lot of interesting discussion in the Jabber room about this. So why don't we, next slide. Yeah, so this is, as the previous speaker said, hop by hop options are not working well on the internet. It's very common to drop them. And so this is a proposal to modify how routers process hop by hop options. Next slide. And I think this was also covered pretty well in the previous talks. Let me go ahead. Yes, and 8200 sort of defined what was how we believe to be current practice, that, you know, when 8200 was done, that, you know, they weren't getting processed in all routers. So it was changed or clarified that you would only process them if you were configured to do so. And this obviously did not improve the situation. Next slide. So, Gory, do you want to pick this up?
Yeah, okay. So our take was, could we find a way to simplify the way in which hop by hop options are used? Because commonly we find paths that drop the hop by hop option at some point along the path. Now, this isn't dropped in the sending node, and it isn't dropped in the receiving node, and it's not even dropped in the first hop. It's dropped a little bit into the path in general. And we know why. It's because people fear bad things might happen, and that's always a good thing to anticipate. And the slow path bit is the most important, I think, of these. There are a number of little pieces, but the ability to push something onto the slow path, we now see as a DOS attack, and we have RFCs that support us in this. So the goal is to redefine the procedures to make hop by hop actions practical. And we know it won't work on all paths, so this isn't kind of saying, hey, we'll write an RFC and change all these routers. But what we think it can do is we can encourage a design and deployment case where it starts to work in places. And the incremental use of this is something you can do and get benefit from with some uses of hop by hop options. So that's what we're trying to do. Get started across longer paths. Okay, we'll go on the next slide, I guess. Who's doing the rules, me or Bob?
Why don't you do them?
Okay, so the good thing about rules is Bob and I are not that opinionated about this set of rules, but we're opinionated at the moment that we should have a set of rules. So this is what we're currently suggesting. And the first one is, let's have one hop by hop option that works. So let's get a spec that says the first hop by hop option must be processed on the fast path. So if it's not on the fast path, then you're not doing the right thing for this option. Additional hop by hop options may be processed if configured to do so. This is our trapdoor to trying to evolve in future. So rather than state upfront that all IPv6 nodes must do something future-proof, well, we probably won't get there. So the option here is have one hop by hop option that must be processed in fast path and allow other ones to be configured to be processed as market, as implementations start to use this. There are implications here though, so carry on listening if you can. Nodes creating packets with hop by options should include a single one. May include more, of course, based on local configuration. And we've said that really, if there are more, then they shouldn't really concern you at the moment unless you're configured for them. So this is a big change in the way we're thinking about how this will be used. You can skip the rest of the options without examining them. Not processed, not even verified. This eliminates some of the complexity. It's maybe not quite as future-proof as we would like it, but it's probably more realistic as a path to go along, which is why we're put it down in this particular draft. Nodes unable to process the hop by option in the fast path must treat it as an unrecognized option. So we would suggest pinning this down and just saying, this is the way to do it. If it's not processed in the fast path, say it's unrecognized. If you want to do something different, then configure it as an explicit configuration, and then you'll be compatible with what we've said. The router alert option we've noted as an exception. This isn't because we're in love with the router alert option. I don't think we really are. It's just, I think the router alert option was always about processing on the slow path. So I don't think there is ambiguity here with this particular option. Now, it might be that we don't need the option at all, and I guess that will be determined by talking about it and figuring out if anyone really needs this. But if you wanted it, it could be a credible exception, I think, to the must process on fast path rule. So there's a point of conversation after we've shown this slide deck. Next slide, please. This is really just the massage with respect to 8200. Some things have to change. We paraphrased a little bit on this slide the words, so read the draft for exactly the choice of words. I had to crop it down to fit it on the slide in a sensible size of font. But basically, we don't expect ICMP messages to be sent from nodes on the path when this is not a supported option. Why don't we expect it? Well, we know that many nodes on the path already ignore this. So this is kind of like a futile attempt to persuade everyone to send ICMP messages. Apart from the processing cost, it just never will happen with every node on the path because there are already nodes that ignore this and don't send you a message. So how can this really help? So if we follow these rules, you discard the packet regardless of whether or not the destination address was a multicast address for type 10, and you can send the ICMP parameter problem. Maybe smart router vendors will send one and then will not send more. There are ways, but you don't have to, it's a may. And similarly, 11 was changed as well to discard packet and may send an ICMP parameter problem. So changes to the 8200 spec and the real words are in the draft. Next slide. Router alerts. The current text says this. And personally, I don't have a problem with this. I've talked with my co-author and we've put it into the ID. And we're happy, though, to listen to other people on this one, I think, because it's just exactly the way it's written here. It could be done, but do we really want to do this? Or has the day of router alert gone, in which case just tell us? Is that fair, Bob?
Yes, that's my view as well.
So next slide, please. Now we get to the kind of probably important bit, because all that was setting the scene. New hop by hop options. If people are going to start using hop by hop options, which we hope this will allow, then new hop by hop options have to be designed for fast path processing. People should know this up front and just be clear about it. They should be straightforward to process. So we don't want massive computation and computation that involve other parts of the router node. And things that can be processed in the fast path credibly. Fixed size and 8-octet units, not variable size, because again, that should help people find headers better. Finding headers is the hidden gremlin behind all this. Where in the stream of bytes do you expect to see the next header? And limit the amount of data that needs to be processed in the fast path. So let's keep this small. Next slide. So we've had this around for a while, and in fact, we're going to ask for wiki group adoption again in 6man as a update. So we're going to ask as part of this meeting today for that. And we've received some issues. The most difficult to answer is what is the fast path or the slow path? What is the control plane and the forwarding plane? This would be something we could easily agree with just any one person in either of these two groups, but getting agreement between multiple people appears to be harder. So we will take advice on what these terms mean. But I mean, it's clear to us that the fast path is the right place to be processing the hop-by-hop option. The node must examine at least one hop-by-hop option in the fast path and can be configured to support others. It must, if a node is configured, then the node must examine, etc. There is an implication here to anyone using this, because if you put two hop-by-hop options in the same IPv6 packet, the second one doesn't meet the criteria of being the first because it's the second, and it might not get through. Therefore, you have to think carefully about how you want to use hop-by-hop options over long paths and what might happen to the second option. This is a constraining factor if we go down this path. It might break some people's ideas of what they want to do with hop-by-hop options. On the other hand, it might enable people to do at least one hop-by-hop option and future get maybe more. So this is a thing to consider if you've got an application that uses hop-by-hop options. Next slide. There's a relationship with the OPSEC IPv6 extension header filtering draft. Obviously, this is why we're meeting together to discuss how to follow on from that draft. We see that draft as reporting the operational concerns, of detailing the things that can go wrong, have gone wrong, will go wrong if you don't do something about it, but don't see this as incompatible with trying to make hop-by-hop options work in the right way in the future. But to make them work, we have to ask, can existing deployed equipment implement our proposal? Our proposal constrains things, but it also places some requirements on the expectations from good equipment. So it isn't a change to the IPv6 base spec. It's not a requirement to implement, but you won't be able to say you implement this RFC if it's finally published unless you do certain things. So this requires real operational or developer expertise to tell us whether we've got the right combination of constraints. To people using it, back to that nitty thing of if you want to set a hop-by-hop option, it's probably only going to be best effort by the path to include it and process it. Some uses of hop-by-hop options will no longer work. They no longer work now is the sad result. I mean, you can't expect this to fix the places where it's broken. But in the future, the first option would be supported by equipment that meets the spec, and the second option, well, that may or may not be processed. I think you might also be able to do some clever tricks by including the first option in a way that helps you know whether the second option is being put through the path. But this is the design of options in the future. Next slide, please. Let's keep going. These aren't specific options to our specific issues to our proposal. Any application or service that uses hop-by-hop options need to work even if no packets are delivered with these options. And there may be some merit, it's not our assertion either way, but there may be some merit on limiting the number of extension headers on the size of extension headers or constraining them to be fixed sizes so that they are easier to implement. So these are not specific to this proposals, but they are things that people might have opinions from, which might influence the way this actually evolves. Next slide. Next steps. We have feedback, we have editorial comments. They're wonderful, and the more comments we get, the clearer we understand, at least at the moment. We think this should be a 6-man document. We think it should be adopted in 6-man, and we're asking for that here because there appears to be interest in improving hop-by-hop processing, and we do plan to work through the remaining issues on the mailing list. Every set of issues that are well articulated really helps us understand what decisions to make. So is there interest in this? The current state we really think is not tenable. We have something specified that's kind of fuzzy. It can be a problem. It might never be used. So let's try and pin it down a little bit more into something more useful. I think that's the last slide.
Thanks, Corey. Thanks, Bob.
The only thing I want to add to this is, and there's been a discussion of this in the chat, that there clearly needs to be hop-by-hop options that have a compelling use case that would cause them to be implemented widely. Having options which people don't want to support doesn't help this. Well, our personal opinion is that the PathMTU one is maybe a good example of something that could be useful internet-wide. Just it's an important internet-wide problem, but building use cases for some of the others is challenging.
And I suppose we will do the discussion at the end and come back to this and Tom's draft. Yeah, I see Ron nodding. Super. So, Tom Herbert, you are next. Are you able to share your own slides? They should be available through the preloaded slides button.
So I requested to share slides. Okay, you see that?
We are seeing it. Go ahead, Tom.
Awesome. So my name is Tom Herbert. I'm going to talk about limits on IPv6 or IPv6 extension headers. So this is a draft I proposed in 6-man. It's not a working group draft at this point. So the overview, so we already know that support for IPv6 extension headers is underwhelming. So this is a little more general than just hop-by-hop options. I will cover IPv6 extension headers in general. The major reason TLVs are hard to process and variable length headers are hard to process in hardware. So it's already been covered. I believe the problem, though, one of the things that exacerbated it was there are a few limits to the usage of extension headers. So for instance, in RFC 8200, the only limit for the number of extension headers or even the size of an extension header, the only limit for the number of options in a hop-by-hop options or size of an extension header is the MTU of the packet. So you could actually put like 300 or 400 unknown hop-by-hop options in a single packet. And obviously, if a router or even an end host tries to process that, it's going to take a long time. And clearly, the only purpose of putting 300 options in a single packet is denial of service. So I believe we need to limit them. And, considering the last talk, this is a little more general limits. So the idea is we want to specify a set of limits for both sending and receiving extension headers. There are various types of limits. So one of the limits is on processing of extension headers. So basically, this would be the number of extension headers, the number of options within hop-by-hop or destination options, the length of options. So all the parameters with regards to variables of extension headers. That would be one set of limits. Another one, which is actually a little more insidious, and there was a little bit of discussion on this in the chat, it's mostly an implicit requirement now that routers have to be able to read transport header information, particularly transport layer ports, in order to be able to filter and even route packets. It's obviously nowhere in any of the standards do we specify that routers have to do that. In fact, the standard probably says they're not supposed to. They're supposed to be able to route solely based on the IPv6 header. However, in reality, we know this is really not true. There are a lot of devices out there that have to read the layer 4 header, which means basically when they implement this as a in a device, usually it's a parsing buffer, so they have a fixed amount of data of packet headers that they load into the fast path processing, 64 bytes, 128 bytes, 256 bytes. If we put a lot of headers in the packet, extension headers, and potentially even other encapsulations, IPsec, what have you, if there's too many of those, it pushes the transport layer header down. And if the device can't reach that far into the packet, some of the devices will actually drop it. So this is a little more difficult of a problem. And the only way to really solve it is to actually limit the number of bytes of headers. So that's the motivation for this limit. Limits also apply both to senders and receivers, but we do want to adhere to the canonical robustness principle for that. So be conservative in what you send, liberal in what you receive. So the way we design the draft is default sending limits. So by default, we mean a host that's sending extension headers, unless it knows that it can exceed these limits, these are what it's limited to send. And I'll get back to a minute how we might have a priori knowledge of what we can send into the internet. And the limits are specified in the draft. I won't go over them in detail. We limit EH to a certain size. We also have to consider padding options. This is already in some of the RFCs, but we limit number of padding options to some logical number. Similarly, data length can have a limit. And that last one is actually the limit on extension header length that I referred to, full chaining. Receiving limits, same thing, but the difference is receiving limits, they are optional. So obviously a host can receive all hop-by-hop options, all destination options, or a router can. But if someone so desires, they could put limits on these. The default limits, for instance, or number of destination options or hop-by options would be 8. And again, there's default limits on padding and the IPv6 extension header length. So the question is, what happens when a limit is exceeded? And this is kind of important because it defines the behavior. And we really divide this into two classes. So one is end hosts that are receiving packets and intermediate devices. General rule of thumb is intermediate devices should not drop just because a limit like this was exceeded. And it's pretty easy. RFC 8200, for instance, already mentions that packets should not be dropped. They should be extension headers should be, or hop-by-hop options can be ignored. So we do extend that a little bit to allow intermediate nodes to ignore some subset of hop-by-hop options. So basically an intermediate node could process the first, say, 8 hop-by-hop options and then ignore the rest. So that is a little bit different requirement than RFC 8200. End hosts, though, pretty much expect it to process all the options and perform the correct behavior. So if a hop-by-hop option does say to drop, it would drop it. There's another interesting use case that we're finding is becoming more prevalent. This is when we have destination options before the routing header. This is kind of interesting because it's actually a cross between host behavior and routing behavior. So the idea is, again, mostly have router behavior, but in some cases, like destination options, it becomes more like host behavior. The sender, as I mentioned, its limits are defaults. If it wants to exceed those, it has to know that it's safe to do so. The question is, how do you obtain that knowledge? So this actually came up in the last IETF when I presented. The obvious one is if we're sending within a limited domain, we would know this information. So static configuration. This is probably going to be the most prevalent use case for hop-by-hop options anyways. That seems like it should work pretty well. More advanced, we could do some sort of probing similar to happy eyeballs. So the idea would be send packets exceeding the limits. If you see responses come back, it's fine. If not, fall back and send packets that don't exceed the limits. We could actually extrapolate this. Probing could be used to, for instance, create a database that maps source to destination. And it's more than just extension headers. We could actually apply this to any sort of advanced features like new protocol, transport protocols. But I don't think the draft is going to, we want to go into this on the draft. It's probably a little bit out of the scope, but we'll probably mention that in a future revision. I did want to touch on the pragmatics and the implementation. I think there was some discussion previously on this. The way to look at this is because of TLVs are inherently a serialized construct. So we have to process them in order. So if there's 5 TLVs and their variable length, we have to process the first one, the second one, and the third one if we want to get to the 4th one. So this is why it's a pretty difficult thing. It's really hard to get out of the serialized nature of that and the variable length nature without specifying that either TLVs have a fixed order or fixed length. But presuming that we don't want to do that, this is kind of what the canonical loop that implements TLVs would look like. And in this case, basically we assume that this is the standard 2-byte TLV header. So the first byte is the type, second byte is the data length. So we look at the first byte. I included the end of list, which obviously is not applicable to hop-by-hop and destination options, but for instance, for TLV option or TCP would be, I believe. So we add that. So end of list just means stop option processing, get out of the loop. Pad 1 byte padding, usually that's 0 type. In that case, we just skip over it. And then if it's not one or if it's not a single byte type, it's everything else. So we have to check, do we have at least 2 bytes of length left? So by the way, the while loop is doing a while loop over the length of the TLV area. And we have an offset that's kind of a pointer into that area. So once the offset reaches the end of the area, the TLV processing is done. So if we don't have a 1 byte option, we do need to do a check if we have at least 2 bytes. So that's what that if statement is. And if that's good, then we have a 2 byte option. Look at the TLV length, which as I mentioned is the 2nd byte. And with the TLV length, we now know what the type is, the TLV length is. If it's pad N, meaning it's multi-byte padding, we'll handle that separately. But if it's not pad N, then usually we'll do some sort of lookup or a switch on the type. And that will return some sort of handler, call into the handler. And if the handler is okay, we proceed. So at the end of the loop, we adjust the offset by the TLV length. So all TLV loops pretty much are going to look like that. And if we add the limits in, this is where they would be applied. So the limits on the extension header chain, the size of the extension header, number of extension headers, this would be applied before such a loop. But everything else, the limit for number of options that we're willing to process would be probably at the head of the while loop. There would be limits on padding, so we have to consider both pad 1 and pad N. There would be limits on option length. that would be applied when we have variable length option. And then we also want to consider limits on non-padding options. So if you put this in, basically what it results in is more conditionals in the data path. So if you look at this from a very high level, what we really can do is consider this a parameterized function. So the parameters to this TLV loop are pad 1 value, the pad n value, EOL type values. The TLV table is that lookup table that matches type to a handler. And then the various limits could also be parameterized. And if we put all these together, then it's starts to see how this could be extrapolated into a high performance, even a hardware function that implements TLVs to the extent that we can't eliminate the serialized part of the while loop, but we could, for instance, do some parallelism inside the handlers, and all the checks and the accounting could be done pretty efficiently in a hardware block. And in fact, that's what my day job is now, is working on this problem. So this draft I proposed a while back. I'm very interested in feedback, whether or not we should proceed with working group adoption, but I guess it's probably part of the larger discussion today, so we can make that part of it. And that's it. Thank you.
Excellent. Thank you very much, Tom. So we'll get back to both Tom's draft and Bob and Gory's, and then first now we'll do a set of example use cases for the hop by hop option. I believe Bob and Gory, you are up first.
A quick note, these use case talks are a strict limit of 5 minutes each.
Hi, I'm Gory, and this is Bob. And one of us is going to talk. Who is it, Bob? Me or you? I've got no audio from Bob, so I think that means me.
Yes.
Okay, so this is the IPv6 minimum path MTU hop by hop option. If you can pass the title slide, then you probably already figured out what this is going to do. But let's move forward. Next slide, please.
Right.
So this tries to address part of a problem, but an important part of the problem. The problem being that PathMTU discovery isn't working well. PathMTU discovery's got two places where it can have real help. One is figuring out when you've got a smaller PathMTU than you might expect, and one is where you might be able to send bigger than you might expect. And you have to have a way to know how big a packet to send. So this idea came forward. It's a different trust relationship to that in RFC 8201, where we specified PathMTU discovery. But it's intended primarily to complement methods like DPLP MTUD, which is the record acronym in the IETF, I think. And basically, this is a method where you send a packet as a probe, usually a sacrificial probe, through the path. And if that probe happens to not be delivered, then you don't know that that size of packet gets through. If that probe packet, which carries no useful data apart from padding information perhaps, or maybe a timestamp, gets through to the other end and you get a reply, you know that that particular size of packet is deliverable across the path. Okay, so there's a little bit more to it, and the draft became an RFC and has been published. It tells you how you might set up a probing method and discover this, but it use essentially a search method where you try packets of increasing size. And how do you know how big to try? Next slide, please. One way you could find out how big a packet is useful to send across a path is to ask the routers along the path what size of path MTU they are configured to support. This is the hop-by-hop option format. If you include this in your packet and the router helps you, it will fill in the minimum path MTU in the forward direction, transfer this all the way to the remote node at the destination, and that will return the return path MTU back to you, so you discover what the routers are telling you along the path. Obviously, not all routers will do this, and many Ethernet switches will simply ignore this because that's what Ethernet switches do. And all of these can be configured with a path MTU. So it doesn't actually tell you concrete information, but it really does give you some information which would help you very quickly determine what your path supports and to discover when that configuration change needs to happen because somebody brought up a link that's got a different MTU. Next slide, please. So this is the basic operation, and I think you could probably read it faster than I could talk about it. The operation we've already mentioned is as a way of figuring out how routers along the path are configured and what MTU they might use. And you could then simply probe perhaps to check that that works, or you might simply believe it and see if your traffic gets black holed. Either way, you could discover very rapidly if some of the routers are configured with different MTUs along your path and therefore choose a suitably big one. Next slide. The status is that this, we think, is a finished document. So we've asked for a working group last call in 6 months. That's been processed. It's now gone to the IESG as an experimental spec, which we believe is harmless to add to your router configuration and can actually offer useful benefit if routers start to update this information and hosts can start sending it. So we think this is a good example of how you can use a hop-by-hop options header, and it doesn't have to be sprouted by every router on the path to gain utility. Thank you.
Thank you.
Then I believe it's Hayo Song who's next. Could you please share your slides and go ahead? Mr. Song, I probably butchered your name, so.
Hi, can you share my slides or the uploading?
They are uploaded, so you can just go to the share preloaded slide button and find your slides there.
Okay, let me share my screen. Can you see my screen?
Not yet. Have you? You need to select the presentation and press the share button, I think, on the pop-up window. Shall I do it for you?
Yeah, can you? That's better. Let me cancel.
There you have the slides, I believe.
Okay, yeah.
Please go ahead.
Thank you, everyone. Yeah, I've been looking at the discussions. I find many people think that IOAM will be an important use case for the IPv6. So there will be some proposals already to actually support IOM using the HBH extension header option. But there were some issues for this kind of proposal. The first issue is that IOM as a choice option does need per hop processing. So that's why the natural place to host it is in the IPv6 hop-by-hop extension header. But by the RFC, IPv6 hop-by-hop extension header must also be the first extension header in the chain. And there are two issues about IOM trees. One is that overhead can be very large because it includes both the instruction header and the trace data collected at each hop. And also due to the data collection, the header size might change at each hop, makes the header a variable length. Also, since the overhead is very large, it can make it very difficult to access the subsequent extension headers because many routers has this hardware limitation on the header buffer size. So if this overhead is too large, and that can make the later headers inaccessible. Especially for the use case like SRv6, the SRH will be located in the routing header is behind this HBH header, then that will be a problem. So there are some possible solutions to this. The first one is IOM. We can basically separate the instruction part and the data part. And since the header part is a fixed size, so we can put it in the still put it in the HBH extension header, and we postpose the data part in some later extension header after the routing header. So, but the issue of this solution is that we need to determine where to actually put the data. Do we really need to design new extension header for that, or put it in some TLAs on some other existing extension headers? So the second solution is we can use some concept of called segment IOM export. There are two basically approaches. In the context of SRv6, we can enforce that we will export the collected IOM data so far only enter each SRv6 node, which means at that place we will first clear all the data collected so far now, and then keeps the HBH header length short. So therefore we can easily access the SRH. But this is only applicable to the SRv6. And in general case, IPv6 network case, we can deploy, basically we can limit the size of the IOM header or head, which means the number of hops we can collect the data. Once we reach that limit, we will export data and clear the data part and start over again then we can use this way, we can keep the header size fixed. The third, we can use the IOM direct export option, which means it's a postcard based. We don't collect data in the header. Only we directly export data out of the forwarding plane. So the packet header size will be fixed. So in the next slide, please. Yeah, in the draft we list several options with pros and cons for each. And the next slide, please. So we would like the working group to reach consensus on the proposed recommendation, and so we can develop the complete solution. If any change and update to existing standard draft is needed. Thank you very much.
Thank you. And Ji Dong, I believe you're up next. Why don't I just share the slides so we'll move on a little quicker.
You can share for me?
Yes, there you are. Please go ahead.
Yeah. Okay. So this is another use case about the hop extension header is to use it to carry the VTN identifier. So let's start,
G,
please.
I think your audio is breaking up a lot. Is it something you can do about that?
How about now? How about
Can
now?
you try to speak now? Otherwise, we can just move you to after the next
Okay.
presentation and
Okay.
see if you can figure out the audio issues.
Okay, how about now? Can you hear me?
No, you're still clipping. I'm not the only one hearing him clipping, right?
He's clipping.
But I'm
He's
hearing
clipping.
you
Okay.
good.
So G, why don't we
Okay, maybe
switch you for
switch to next one.
for
Next one?
Giuseppe's. And then you can see if you can figure it out and come back to us. So Giuseppe, do you want to? I can share the
Okay.
slides for you.
Okay.
Let's see.
Can you hear me, sir?
We can hear you fine. Possibly you have to. Oh, there we are. Sorry. A little bit hard to find in the system. There you are. Please go ahead.
Okay. Yeah, this is just few words about another hop by hop use cases. That is the alternate marking application for IPv6. So next slide. Yeah, just few words about what is the alternate marking. Is an OM passive performance measurement technique that allowed the measurement of packet loss by switching the value of a bit called loss flag. And there is also another bit called delay flag to create a new set of packets that can be used for delay. There is also another extension of this alternate marking methodology that is called multi-point methodology that generalizes the application for multi-point flows and allows also the possibility to have flexible performance management approach. Next slide. So how do we apply this methodology in IPv6? We define in general new options that can be encoded as hop by hop or as a destination option. Now we are talking about hop by hop, so focus on the hop by hop use case. And you see that the options is the same. There are two flags, the loss and delay flags that I have explained in the previous slide, and then we have the flow monitor identification field that is required for several reasons. For identification, to allow easy collection of data, and to also in combination with source and destination address to select the flow to be monitored. How it works, the source node is the only one that writes the option header to mark the flow for both hop by hop and destination option. In case of hop by hop, the option header, it can only be read by the intermediate nodes if they are configured to do so, and the measurement is hop by hop. In case of destination option, of course, the measurement is end-to-end. Next slide. In the draft that is in ISG evaluation phase, we address the alternate marking hop by hop use case. I don't see the next slide. Okay, thank you. Yeah, and the draft address the hop by hop use case consideration, and in particular, the hop by hop option allow, as I said, measurement on every router if the feature is enabled. In particular, because in many cases, end-to-end measurement is not enough. So we want to monitor hop by hop. Nodes, of course, examine and process the hop by hop if are configured to do so. This is based on RFC 8200. And nodes that do not support hop by hop should ignore them. So in this case, the measurement does not account for all links and nodes and along the path. But this is not a big problem because, as I said, the intermediate nodes don't have to handle to modify this option on the fly, so they only need to read. So if they support or not, this will not affect the performance measurement. So, of course, in the draft, we also highlighted that this hop-by-hop option is designed to minimize impacts both on nodes that do not recognize this option and on nodes that support this option, because the 3 high-order bits are all 0, and this means, in theory, that you have to skip if you don't recognize and data do not change in route. In addition, one of the preconditions for the application of this methodology is the controlled domain limitation, and this should also avoid the risk of arbitrary nodes dropping packets with hop-by-hop option. Anyway, in practice, we know that the things may be different, the implementation, and it can happen that packets with hop-by-hop are forced onto the slow path. Next slide, that is also the final slide. So, in summary, it is desirable to modify the hop-by-hop processing to make hop-by-hop option more practical, also to allow further uses, including alternate masking telemetry. So we welcome all this work and new activity on hop-by-hop processing. Thank you.
Thank you, Giuseppe. Excellent. So, G, let's see if we can get you back on again.
Can you hear me?
We can hear you. It sounds better now.
Okay, good. So this is another use case of the IPv6 hop-by-hop extension header to use it to carry the VTN identifier. Okay, next slide, please. So here's the background. A VTN is a virtual underlay network consisting of a set of dedicated or shared network resources, and it is associated with a customized logical topology. It can be used as a virtual underlay to deliver one or a group of enhanced VPN services, and the typical use case can be network slicing. For more details about the background, please read the draft and this draft, and also the enhanced VPN draft in TS working group. The identifier of the VPN needs to be carried in the data packet and passed by each hop along the forwarding path, so that it can be used to steer the package to use the set of resources allocated to the VPN for the processing. So that we think the hop-by-hop extension header is the suitable approach for this case. And this document proposes a new hop-by-hop option to carry this VTN information. Next slide, please. So here's the proposal. We propose to define a new option type for the VTN resource identifier in the hop-by-hop header. The first 2 bits are set to 0 so that it can be skipped when unrecognized. And the third bit is set to 0 so that it will not change in the route. Then there's a 4-octet VTN resource ID, which is used to uniquely identify the set of resources allocated to the VTN. And follows other procedures in the network. Basically, the ingress node should encapsulate an outer IPv6 header and the hop-by-hop header with this option based on the traffic classification and mapping policies of the operator. Then the transit nodes use destination address to determine the next hop, and use the VTN option to determine the set of local resources allocated to the VTN for processing. On the egress node, of this domain, it should decapsulate the outer IPv6 header, including the VTN option in the hop-by-hop header. Next slide, please. Here are the operational considerations we described in the draft. We know that according to the RFC 8200, network nodes may be configured to ignore the hop-by-hop header, and there can be implementations to drop packets due to the hop-by-hop header. And luckily, the hop-by-hop processing draft is working on the solutions to solve this problem. And we would like to see that draft making progress. At the same time, operators, before we have this mechanism ready, operators need to make sure that when they use the VTN mechanism, all the network nodes involved in the VTN can either process the hop-by-hop header in fast pass or ignore the hop-by-hop header. So a practical approach is to ensure that all the nodes involved in the logical topology of the VTN can support the processing of the hop-by-hop header and the VTN option. And this ensures that the packets will only be sent on the path computed within the logical topology. So that's all I want to introduce as the use case to this working group. And by the way, we have requested for the adoption call in the 6-month working group. Thank you.
Excellent. Thank you very much. And I think we're now up for the discussion. Ron, do you want to?
Yes. Thank you very much. I'll bring up the discussion questions again. Hang on just a second. Okay, we have two sets of questions, this set and this set. So let's open the queue for anyone who wants to address any of these questions. I see lots of chatter in the chat room, so I assume some people would like to bring their opinions forward.
We also have Fan and Edward in the queue.
Ah, I see. Okay. Fan. Fan, you'll have to unmute yourself. Okay, let's skip to Edward.
Do you hear me?
Yes, I can hear you now.
Okay, fine. For all solutions which I have heard, not just today, but in the mail alias too, I could classify as a 3 type of solutions from my point of view. The type of solution number 1 is we enforce people to use at least one header or at least one option, at least something. Yeah, it's an enforcement. I don't believe it's possible to enforce from IETF. It's possible to enforce people. If people does not have business case, they will still continue to filter out all this. Doesn't matter that particular RFC will tell, okay, you must. And then IETF would have not a good look, because IETF is asked should, must, or whatever, but people will still ignore. It's not a pleasant situation for IETF. Therefore, enforcement, from my point of view, is not a good idea. The second type of solutions, which I have seen a lot, it's restrict something by numbers. For example, tell people, okay, you will not have more than 3 headers or then 3 options, whatever, restrictions. But sorry, how it could help if currently people does not have even business case even for one option, for example. They don't support even one, and you tell them, okay, you will not have in the future more than 3. Will it help? Of course not, because they don't want even one. But it's a bad thing for the future, because if in the future we will need some protocol expansion, and this restriction could limit us on the future. Therefore, I am against any restriction. Doesn't matter which one. As soon as you will put, okay, let's restrict by number of headers, by size of option itself, by whatever. Any restrictions, it looks not good, because we could not even start first option. And the third type of solution, which I have seen today, not just today, that change somehow architecture. Principally tell something, okay, for example, let's classify some options as a soft options, which will go to control plane, and other options as a hardware options, which will go, should be in the data plane. Okay, this is not numbered. This is some principal change. For such things, I'm supportive. I believe it's probably makes sense to try. Probably it will not help anyway, from my point of view, because I have a discussion in the chat that there is no business case. As soon as business case will be visible, immediately everything will be fixed, no problem. But we could try this, because, for example, this particular solution, soft and hard separation, and something principle change, how mechanics operate, some architecture change. This one I support. That's it from my side.
Okay, thank you. Tom?
Back to something that was in the, I believe it's Bob's draft. So you mentioned that RFC 8200, when we made that change, it didn't have an impact. Do we have data or some information that that's true?
Okay, and I think that's a
Well-
question for Bob.
Yeah, I guess I would say it seems like that the situation with hop-by-hop headers has not improved since 8200 was published.
But so my question was more, have vendors adopted that, and are they planning to stop dropping packets with hop-by-hop options and just ignore them?
I think that's a lot of the current practice we observed.
I
Well,
just wonder if
and
new
just to-
devices are continuing
just-
that.
Yeah, I don't know, but just to clarify, what we did in 8200, because we were moving it to Internet Standard, was to document the current state. It wasn't asking anyone to change behavior. So we documented what we thought was actually happening in practice.
Right, but there's also a perception that there's a lot of routers out there that are dropping any packets with HBH. And
If I
RFC
could-
8200 is trying to mitigate that by saying, don't drop, ignore, which would be much better.
If I could jump in a second. The default behavior for most routers is to punt to the control plane. It can be configured, a router can be configured to drop a packet that contains HBH. And recently I know of at least one vendor that has a new switch that says, ignore the HBH, pass the packet, don't punt it, don't drop it.
That's the preferred behavior, would be to ignore as opposed to punt. So I don't know if we need to maybe have another document on that, best practices or something like that, but I think that would be a big thing. That's a lot of the problem. If we could just have router vendors ignore instead of drop, that would get us halfway, I think, to solving the problem.
Okay, Pascal?
Thank you. I wanted to say that the hop-by-hop is already used very successfully in the IoT in the context of report networks. And the hop-by-hop header has to be looked at by every node. It contains topology information, which is very similar to the VTN. And it also contains loop avoidance information, because Ripple is reactive in fixing the routing just to save energy. So that's one thing. So very successful, very useful. And the other one is we have yet another use case for hop-by-hop in the context of DetNet. In this case, we are not signaling a topology. We are more signaling something like a path where equal treatment will be received. And then again, there's a need to look at the header, at least the one that indicates the path, on every hop. Both cases, Ripple and DetNet, would be limited domains, which has me ask you about this question that was asked in the chat as well. What do you mean by internet-wide interest? Because these are limited domain, but the interest is huge. Right? Those domains can be somewhere everywhere in the internet, but not across the internet probably. So
Okay,
does that pass the bar of internet-wide interest or not?
Not sure, but let's continue this conversation though. Shuping? Shuping, you'll have to unmute yourself.
Yes, I already did. Hello, can you hear me?
Yes, you're on. We hear you.
Oh, good. Okay, so first of all, thank you. Thanks the chairs for arranging this dedicated session for this hop-by-hop, so we could discuss and seek the proper solutions. And there are some use cases as just presented by the several colleagues here, and the hop-by-hop is a real problem. And we could say it is a headache for the operators. You could see from our V6 ops, the draft, there are 3 operators. That was actually asked by the operators. They want to solve it. They want to actually use the hop by hop options headers. And currently they just, they have to block it. And currently we are seeking the solutions as progressed in Bob's draft, which is good. But, and also you hear there are some questions you listed here. They are worthwhile to investigate. But there are something else. I keep it in the draft, in our draft, that is about migration strategy. So once we have the solution, we still will have to consider how to actually use it. So to do like make it really usable in the real network, and how to make the hop by hop coexist with I mean the new device which could support the hop by hop. They could coexist with the existing devices. I think that is really important things for us to consider. Thank you.
Okay, thank you. Jen?
Okay, can you hear me, right? So
Yes.
I'm really happy to see this discussion happening, but at the same time, I'm a bit surprised, right? There are definitely people who want to make this work. So I see no reason to even start talking about deprecation or not rehabilitating it unless there are proofs that it's dangerous, right? So I think, yeah, we should keep exploring options on how we can make those things useful. And I believe nobody gonna enable proper processing across the internet until we find a compelling use case, right? So we should start like solve this chicken and egg problem, but finding a use case for them. And then, yeah, I'm quite sure that if operators find them useful, they will enable processing, not before that, right?
Yes. Okay, thank you. Cheng Li?
Wally. So I strongly support to move the work forward to find some like good solution of hop by hop. Definitely we need it because, you know, as the development of the technology, we need this kind of usage. And the technology is defined for human, for people, for business. So our customer want that and we want that. So let's do it. Thank you.
Thank you. Cheng Fang? Chongfeng? Chongfeng, you'll have to take yourself off of mute. Okay, we'll come back to you. Warren?
Okay. I support the work of HBH, and I think it should proceed. And that means that we should rehabilitate HBH work, HBH option headers, because it can support LVM, MTID, and PMTU options, are not a function. Frankly speaking, I don't think they are services. They are some functions of network. So I don't think they are services. And another issue is that about the current status of hop by hop options. Frankly speaking, the hop by hop option has not been widely used by operators, but this does not mean that operators oppose hop by hop option because they don't know how to use hop by hop options, because this is a new thing, right? So so I give support to this work. And also about the documents, I think we should make a draft about the requirement of HABH. This should be comprehensive. We should consider many factors in this draft. That's my comments. Thank you.
Okay, thank you. Warren?
Thank you.
So I mean, I was originally going to save this for the end, but figuring out exactly when at the end of the session /Q is tricky. I just wanted to note that when we'd originally discussed having this sort of joint session and focusing on hop-by-hop processing, we were, or at least I was, a little concerned how the session would go. You know, would everybody actually try and get together and solve the problem, or would we instead devolve into shouting at each other? And I just want to note how really impressed and happy I am with the attitude that everybody's had, and how well people have been sort of trying to get together and recognize the issue and also discuss how we can move out of this. So sorry for the sort of touchy-feely bit, but I'm really happy with how this has been going so far.
Well, thank you. G?
As I mentioned, I really supported the work on this hop-by-hop option header. As we can see, we already have several use cases or applications in the limited domain. And before we can deploy for the larger domain or even the internet, for some other cases, we need to get the technology ready. We need to have this documented in the IETF standards to guide the implementation of the vendors. So I think this is really important to make use of this extensible feature in the future. So I think that is my support to this work. Thank you.
Okay, I see the queue is empty. So I'll open it up for some further questions. First is, oh, G, oh no, you were just there. Okay, I'll open it up for some further questions. I know that I've heard some support for continuing the work. I know we don't make decisions at meetings, we make them on mailing lists. So chairs will get together and figure out how to do, well, it's not quite a call for adoption, it's how to put out a decision, or how to get more feedback on putting out a decision. Assuming that we do go forward with the work, I'd like to look at the last two questions, and this is assuming we go forward with the work. Do we need to re-examine some currently defined HBH options? I'm thinking in particular about routing options, and maybe some of the ones that are just hanging around from prehistory. You know, some of the very old ones that really should be historic. And the other question is, what kind of work do we need to make this progress? What documents do we think we need? And I'll open the floor to comments on those two questions. Okay, Gory?
Yeah, surely we can look again at the list of hop-by-hop options and other options and find some dead wood in there. Bob and I started this before we wrote anything, because we wanted to understand what really existed, and some of the stuff doesn't really exist that we have in the RSC series. I'm not sure it really helps that much. It may help you with the size thing, because you may discover that all the really odd size things don't actually exist. So at least from the size, it's good to look at them.
Okay, I'm going to put myself in the queue, and speaking with no hats on at all. The one, you know, getting rid of the dead wood is nice, but it doesn't do very much for you, except for one piece of dead wood, the router alert option. And that's the one that typically crosses the plane from forwarding to control. How do people feel about deprecating that one? And Shuping, you're next online. Shuping?
Already defined, and but whether to deprecate, I'm a bit I'm not sure whether we might make some trouble on this, and how to guarantee we won't do it wrong. I mean, when somebody's still using it, and because you never know, and that is my thoughts on this. A bit conservative. And regarding the documents and work, definitely, the requirements was just mentioned by a comment. And in our draft, we have a dedicated section on these requirements, and we will work more on this. And that is our key focus later. So you are welcome to join us and to make it more reasonable and to guide the solutions. So that is my comments here. Thank you.
Okay, Edward.
On what to do. From my point of view, IETF has one big problem, which is everywhere for all working groups. That if you will try to understand some particular problem, for example, in this case, hop by hop or whatever, you need to read basic RFC, of course, and then you try to search and find all other RFC which is related, and it's really research. You need to do a big research, which is more or less possible to do for vendor, but okay, it's a challenge, but it's completely not possible to do for carrier. Therefore, for carrier to understand all these nuances or all these problems around hop by hop, it's really mission is impossible, because probably he need to read a few dozens of RFC, and it's not what is it's not his job. On opposite side, let me give you an example of what is going on in Wi-Fi Alliance, for example. You know, in Wi-Fi Alliance, whatever they develop, they're trying to incorporate in one primary document, which they trace from the history. Currently, and as a result, they have something consistent. It's always possible to take just one file, just one latest document, and read everything. Unfortunately, it's opposite extreme, because in their case, the last document is already more than 5,000 pages. It's, of course, it's not good. It should be more or less structured. It's the opposite madness. But the madness which we have in IETF right now, then it's scattered everywhere. It's up to particular working group, particular chairs, particular AD, that some particular working group could start to formalize everything properly. Because, okay, if you have some particular problem, it should not be scattered over the dozens of RFC. It should be some number of limited RFC. You should not read everything. You should not become an expert to understand. It's a really big problem from my point of view. It's everywhere, and hop by hop is a good example. Sorry.
Okay, thank you, Edward. Eric?
Yeah, let me first thank you again to the chairs for organizing this and running it correctly. As you know me, most probably you know that I want to keep hop by hop working. And I'm a little bit unsure, ambivalent at least, regarding the deprecation of some hop by hop options, because it's not because you will deprecate that the code will be removed from existing routers, specifically very old one. Now, I would suggest maybe we can go like a best current practice to not enable them rather than deprecating them. That may be a little bit more operational issue towards a standardization issue there. And as other people said, router alert for MLD is required, because MLD are sent to the multicast group, right? So if you want to snoop them, you need to get a router alert to go to in the slow path. So that's one point. And yes, let's continue the work on the document for sure.
Let me ask a question, since I see the two Erics in the line, about what deprecate actually means. I think it means that if an option is deprecated, it can still be used by the protocols that use it. For instance, router alert is used by MLD v2. It can still be used by him or by that protocol. But new protocols cannot use it. Does it mean more than that?
I need to check, to be honest, Ron. There's a very specific questions and very important one.
Yeah, I know I should know that too, because
you have been an AD as well, right? So,
yeah, I don't know what it means.
Well, and by the way,
Okay.
I was speaking without any hat. Sorry.
Yeah. Okay. Thank you, Eric.
Jump in on that a little bit. Yeah, usually means what Ron says, and that's like when we've deprecated other things, the deprecation document usually defines it specifically for what it's deprecating. But usually it means we're not the protocol police. It doesn't turn anything off, but just don't use it in the future.
And in practice, it can never be reallocated, really, I think. I just want to say, with respect to working group documents and progress, as a responsibility for Six-Man, we should be having an adoption call for one or more of the documents, Six-Man documents you saw today in the coming week or so, I would expect. Up to the chairs, but I would expect to see one soon. So I would encourage everyone to take the time to go read those documents and to make your comments known now or during the adoption call. Thank you.
Okay, thank you. Warren?
Yeah, others, especially Bob, largely said what I'm going to say. Deprecates is kind of like updates. Nobody quite knows exactly what it means, but when you deprecate something, generally you explain what you're meaning by it when you put it in the document. And yes, this is a problem and everybody knows it's a problem, but we haven't solved it yet. So, oh well.
Okay. So I see the queue is clearing out. Does anyone have any final comments? Chairs, anyone? Any expected activity? And then, oh, I see Eric has joined the. Eric?
I wanted to echo some of the things that Eric and Warren had said, to thank all of you chairs for putting this together, all of the authors and presenters for taking the time, and for everyone who came to this session to try to see what path forward, if any, might be made. So I appreciate everyone's efforts to try to figure out in what direction we should all be pulling. Thank you all.
No, thank you. And chairs, any comments on what we think next steps are? Fred. Fred. Fred, are you in the queue?
Finally figured out how to unmute myself. I asked Tom to write a draft for Six-Man on a BCP for ignoring HBH document options. So that is at least part of the path forward.
Okay. I'll propose a few things with no hats on at all, just kind of a wild guess. I'm thinking we probably need something like the 3 documents we saw presented at the beginning of this session: a requirements, a solution, and a limitations. Not quite sure if limitations and solutions should be merged into one or not, but I'll leave that for the authors to discuss. Does anybody think we need a document to look at house cleaning, deprecating, dead wood and possibly the router alert? Fred. Fred, are you on the queue? Okay, Fred first, then Bob.
Okay. I thought I had unmuted myself. I guess not. Anyhow, but I would agree with you that an omnibus draft deprecating a few of the options, or router alert is an obvious one, would be in order.
Okay, thank you. Bob?
Yeah, I was going to say that it's good to write proposals down in drafts because then the issues can be discussed better than just talking about it in email or presentations. So I think, you know, if someone did want to take a look at the existing options and maybe do some evaluation and make suggestions what to do going forward, it would be useful to discuss whether that document ever, you know, gets finished in advance. That's a whole separate discussion.
Okay.
And I also, just while I got the mic on, so I think this has been a useful session to talk about these issues all together. So.
Okay, Gory.
Yeah, I was going to come back on the deprecates and meaning for something like router alert, and just comment that, you know, in the chat, Bill Fenner and I were both commenting, well, there's layer 2 equipment that sets this and consumes this, looking at MLD packets, for instance. So we might want to think about what deprecate really means for router alert. Maybe it means don't use it on internet paths. Maybe only use it for specific protocols or something. So there's probably something to write down here, I think, that might be useful.
Yep. Okay. Any others? Well, if that's it, I thank you all for your contributions, and we'll continue to discuss this on both mailing lists. Till then, I think it's time for us all to go get coffee. Take care, all. The meeting is closed.
Rest of your day.